All right, so what I'm going to be talking about is how Redis has helped us get to where we are. So just to give you a context, why near, why ambient, the first couple of slides give you an overview. So what is our mission, right? So primary thing is we're collecting a variety of different types of data sources, static and streaming, indexed by location from different contexts, and then basically process it at scale. And the value prop of this is there are a variety of applications that we see, sort of real-time analytics and also sort of analytics at an enterprise level, which can be powered by this. So why near? Because so near sort of reflects our focus around location. And what you see in this picture is sort of the various kinds of data sources that we process, from traffic to telco data, to Wi-Fi hotspot data, spend data, event data, real estate data. If you look at it, location is very fundamental dimension in all of this. The thing about location is it's just not lat long, it's available at different levels of abstractions. Sometimes it's a polygon, sometimes it's a region, and then in each vertical there are different ways how people map location. So from how folks compute census, using a census block, it varies. So how do you link all of this and make sense? Right, and our value prop is, the reason we want to do this is understand sort of mapping out a consumer's journey, as we call it. So before jumping into sort of how we got here, this is where we are right now. What this picture shows is the different subsystems. So data streams in, which is the sources. We do a whole bunch of things around analytics on the type of data coming in from the different sources, how they are linked with each other, keeping track of those things. And then the big thing that we do is these location pings that we get globally, we actually map. I'll show you some pictures down the line, which shows sort of how user activity can be visualized. Right, and then there's a whole bunch of inferencing we do based on the patterns of user movement. So there's basically human mobility analysis. And then one of the things we do is the real-time audience segmentation is not only I want to know about an individual user, what's actually of more value is groups of users. So how do I define a group? How do I track them? What do I want to know about them? Right, and this whole pipeline, the real-time pipeline is powered by a lot of back-end systems where we've got to keep track of the analytics, the ID system, resolving things across IDs from different sources, the profile cache where we do updates, the count store. Everything on the top there is actually powered by Redis. And then there's also batch analytics at the bottom. There are sort of Redis subsystems we use there to keep track of things. And then all of this is actually exposed by a whole series of APIs. Some of the signatures are real time, some of them are async, some of them are sync. And they power sort of two key sort of product areas for us. One is AllSpark, which is our core SaaS product built around audience curation or built for audience curation. And then sort of data as a service APIs. Depending on the use case, different enterprise scenarios require different kinds of data and different cuts of data over different time periods. Right? So right, and then we also pipe data into external systems. That platform that you saw powers our core product called AllSpark. What you see, hopefully at the end of the talk, if time permits, I'll sort of show you a live demo. What we have is sort of this notion about defining audience segments, which we call cards. You can track analytics on that real time. You can actually also do spatial analysis on these cards. Let me give you an example. Maybe I'll just do the live demo. Give me a sec. Oops. So this is actually a live product running live. And what we have is this is actually live across about 20 plus countries globally, just to give you a sense of the scale. Just to give you sort of, let's say we wanted to find out how many meals visited, sorry, McDonald's, let's see, in, let's say, San Francisco. So what this basically shows real time, what we have computed is the 20 McDonald's locations in the San Francisco city area. And what shows on the top right-hand side, the 1 million, is the number of visitors or pings, uniques that have come to those McDonald's in the past 30 days. And the interesting thing is, this is just sort of the basics. What actually customers want is to slice and dice this from different perspectives. I won't get into the detail, I'll talk about this along different dimensions and do this in real time. Much of the functionality and the model building behind this is powered by Redis, just to give you a sense. And then there are additional functionality. For example, let me just go here. So you can actually build cards. You can actually engage with folks on the cards. So basically run different kinds of marketing campaigns, and you can get different kinds of analytics. Right? So basically powering how you define segments and engage with them. So to get here, 24 months ago, and part of our vision, where we were was sort of initial prototypes. We are processing about 20K events per second. We want to get to about 200K events. And then there was traffic with and without location. And the big thing was, how do I take this and map to the physical world at scale, right, across different countries, right? Not only that, the same IDs, if the same users came on different sources or across different apps and so on and so forth, how would I link them together so that I can build an aggregated anonymous identity? So how do I accumulate, summarize, analyze, and then how do I expire? And then on top of that, we are actually, based on the traffic and stuff, we are making a bunch of model-based inferences that we wanted to update many of these counts and so on. Where are we now? Right, we process about 150,000 events per second globally. So we collect about 6 to 10 terabytes of data from different sources. We have data centers in pretty much the key cities globally. We have geodata from about 44 countries. So you saw on the drop down on the left-hand side, we have activated about 22 of them, another 20 to go. And then we accumulated about 1.5 billion profiles globally, right, which get updated every 90 days. They accumulate, they expire, things change, so on and so forth. Right, and people have defined nearly 3,000 audience groups. Each group could contain 3 to 5 million IDs based on over a given time period, right, and then run sort of 1,000 plus campaigns. So what did Redis help us do? So basically the key thing is, though we had the big vision at the start, how do we go there, what works, what doesn't work? It helped us actually develop incrementally, right? Different data structures were not known a priori. What works, what scales, what needs to be real time, what needs to be offline. Many of these decisions we did not know when we started, right? And sort of Redis helped us sort of experiment, support the production version as we sort of built out the prototypes for different functionality, right? So help scaling of key subsystems. The other thing is the data structures, right? Should I use a hash? Should I build something in-house? Should I use some Mongo? There are so many design questions, right? And the trade-offs are different depending on the scale and depending on what you want to do. You might build something that's never used. So part of the thing for me, the key thing is help the tech team sort of navigate this. Our part of the strategy was first build everything basically in Redis, get it out there in front of the customer, test it, then come back and re-engineer, depending on the scenario because the product management also evolved along with this, right? And then sort of the other key thing is there's a lot of sort of discussions on different ways of how to combine real-time pipelines, batch pipelines, so on and so forth. Can they share data? They are at different time scales, right? How do you know the time scales a priori unless you sort of actually collect the data and analyze? Again, Redis was a fundamental sort of glue where we could keep a common framework and share across different pipelines. So we use Tom and MapReduce, Hadoop basically to do that. Some of the key subsystems that power the current infrastructure. So one is the ID system. So for different sources, it has to generate IDs. It has to deduplicate. So when a new ping comes in for a device or from a source about a device, we have to check if it already exists in our system. Right, so then we have to deduplicate. Opt-out management, and depending on the type of source, depending on the type of conditions, there are opt-out scenarios where they say, hey, you see my ping, don't process it. We have to filter those out, right? Then a single internal ID, which we call the Allspark ID, it has mappings onto different sources because sources need to be kept separate. Privacy requirements change, or somebody shuts off the feed, then everything changes, right? Everything else sort of breaks down. The whole data structures get corrupted. So we had to partition and maintain it separately, right? And then the big thing for us was to understand the overall incoming traffic from the different sources. What's the mix? How does it vary during daytime, nighttime? And globally, the patterns are very different, right? So when you have to analyze globally, you really need to get to the nitty-gritty. This is one key subsystem that's powered by Redis. This is the one that I showed you earlier in terms of doing the estimations, which is sort of what we call the grid store. What you see is a picture on the right-hand side is Australia. Over a 30-day period, the pings that we have accumulated across different sources, right? Every dot there you see is a HLO, right? And so you can imagine the number of keys. How do you grid this? That's also a design decision. We have grids at multiple resolutions, again supported by Redis. Right? And then this is done for all countries. Right? So right now we have for 24, we are scaling it out for the rest of them. Right? And this is very fundamental because anytime I can go look this up, visualize and say, hey, what happened? Why did it happen? So when a new source comes on board, this thing changes. Right? What are the hotspots? Right? What do I need to change? How does my underlying algorithm change? How does my estimation model change? This is very key that drives our data science and overall analysis. Right, the another one is sort of a different kind of counts, where once these audience segments are defined or groups are defined, we want to keep analytics about them. As people move about, we get different kinds of pings from them, right? So again, how do you track them? How do you identify? How do you sort of externalize and run MapReduce or whatever else you want to do, but the initial correlations need to be estimated right there. So for that, we actually use Redis. Right, so this is one of the very fundamental, gave us great insight into how consumer journeys and their patterns vary from country to country, even from metro areas and suburban areas. One of the things that we do use this also, sort of Redis powers a bunch of things in our RTB engine. So metrics on the incoming events, what we bid on, right? What are the response events? So this is one of our initial applications. But the key value that we are working on right now is sort of using it for optimization. Because in a 24-hour window, a lot of things happen globally. Right? We actually see US apps ping for ads out in Japan. How do you handle it? What kind of optimizations can you do? So Redis actually helps us there at scale. Other use cases in the current pipeline, real-time analytics. So every subsystem actually, when we track the metrics, it's actually done in Redis, then piped into Grafana for visualization, right? And then a variety of analytics where we cache. So some of the things that we do based on samples and sampling, daily samples, how do you update the samples? All of that functionality is actually implemented in Redis. So that's the audience analytics, right? And then powering model as a service. So many of the models our data science team builds that needs to be measured against live data. So one of the classic problems is our test data is a very small sample of the real world. So things change very, very quickly and we need to update. Right? So to even detect the alerts, detect the deviations from the model, we use Redis to actually track the analytics. And as I mentioned earlier, shared state across real-time and batch pipelines. A current deployment. So primarily we're using open source Redis. We have been sort of hacking this for the past 2.5 years. 60 plus high-end servers across all the data centers. RAM requirements, depending on the app, depending on the subsystem, range from 128 GB to 512. Each of the subsystems has independent clusters, right? And then the backup and stuff, we have figured out how to support it, right? How to manage sort of the save GB or whatever, I forget the backend, right? And So a bunch of things around maintenance. And then we also know when things are going to fail based on the traffic, what's happening. So a lot of sort of tribal knowledge that's developed in the tech team. Ad hoc issues, yeah. So this whole snapshotting, what to archive, what to backup, right? Append only file, right? Can we do a combination of the two? How do you change during runtime, right? And then the other big thing with sort of open source Redis is managing replication. So we have built our own machinery to replicate across the different data centers. Right? And then one of the key things from a developer perspective is our key descriptions are so complex. There's so much semantics embedded. So if you go look at the code base, let's say a couple of months down the line, you download it from the repository and go look at it, it's very confusing. Right? So it's a part of the thing that we have to deal with is document what the key representations are. Right? 5 or 6 dimensions are sort of plugged into that key separated by colons. So if somebody flips something, it's a mess. Right? So part of the thing is getting disciplined about key generation. What should we do? And that's a time when it becomes big enough, or the key becomes very complex, you really have to start thinking, okay, do I need to externalize it? Which parts do I need to keep in Redis? Which needs to go outside? As I mentioned earlier, benefits, enabled incremental development. The other key thing for us as a team, we're a very small team and a lot of folks sort of joining us. The key thing is I can get developers of varying ability work on developing a scalable system. So core data structures, things like that, okay, put it into Redis, and then build the rest of the stuff around it. And then we can, right? So nobody actually has to actually worry about if I use Java hash table, how big should it be? Worry about GC and things like that. So a lot of core subsystem development was handled this way. So for us, the team had a range of developers who could actually develop a system of this complexity. Right? And it also allowed people working in different languages. So we are basically a Java, PHP, and Python shop. Right? And different subsystems require different languages. People are familiar in certain things, but they at least can work off a common platform, a data platform that powers their needs. And then sort of the key thing, it's helped us sort of delay design decisions, right? Sort of principle of delayed commitment. I don't have to decide between a relational DB and sort of something like Couch or Mongo, right? Let me wait, let me scale, let me test, let me get user engagement before I decide. So Redis sort of fits that sweet spot. It's neither a full DB nor a completely sort of NoSQL kind of thing, right? I don't know my indexing, what I want to do on Mongo, but I need to get something up and running. And you get a pretty decent scale and performance. So it's actually a very useful tool in an architect's toolkit. What next? We are sort of seriously evaluating enterprise Redis. We are at a scale where, right, we want to go away from RAM to use the flash. So there is a trade-off there which we are seriously exploring. And then there are a whole bunch of other sort of databases that we use. Those of you are familiar with key value stores, KT is used to be one of the popular ones. Elasticsearch, Mongo, Cassandra, and HBase. So our data is spread at different time scales, different attributes, different cardinalities across all this. So part of the thing is start in Redis and then it moves to these things. And there are some things we are seeing may have to come back into Redis. So there's a whole iterative design activity underway. And then the other thing is recently we have started looking at Redis. Some of the key things that on the real-time analytics is to see what kind of alert generation can we do. Sort of flagging sort of abnormal events and so on, right? Some kind of ML classifier on the edge. But there are different kinds of, we are sort of in the process of testing it. Right, I'll stop here. Any questions? Hopefully give you a sense of how Redis can play a key role. So see the scale it helped us achieve. I haven't gone into the nitty-gritty because a lot of it is, yeah, go ahead.
How do you achieve across data center replication?
So one of my colleagues is here who actually built the stuff. You want to answer that?
I can't hear. I'm sorry.
We can talk offline.
Oh. Okay. Okay, thank you.
Are there any internal tools that you are using to do this rapid prototyping with Redis, or just straight connections to it?
I didn't hear you properly. Go ahead. Sorry.
Are there any internal tools that you guys kind of developed to make this rapid prototyping with Redis easier?
No, not specifically. I think the key thing, what we spend time as a design team, the key is designing the keys and what data structures. It all looks very easy. Sorted sets, everything is there for somebody who wants to hack something very quickly. But once you commit to it, undoing it is a big pain. Right? So part of the thing is that initial discipline to design properly. We didn't have any specific tools, because it's quite straightforward to get up and running.